Good morning friends, just we discuss about the forward bias and reverse bias of PN junction diode, and also we discuss the characteristic of forward bias and reverse bias. In forward bias, the electric current is flowing through the PN junction diode due to the majority charge carrier, and this current is in order of milliampere. While in reverse bias, the current flowing through the PN junction diode is due to the minority charge carrier, that is in order of microampere. It means during the forward bias connection of the PN junction diode, only the current is flowing through the PN junction diode. While during the reverse bias, no current flowing. Current is flowing, but this current is very small, is in order of microampere. And due to that reason, the PN junction diode is used to convert the AC voltage into the DC voltage. That means the PN junction diode is used as a rectifier. So first thing, what is the rectification and what is the rectifier? The process which convert the AC voltage, current or power into DC voltage, current or power. Again, the process which convert AC signal into the DC signal. Why the DC signal is required? At present we are using the mobile and most of the electric components in our house that is working on the base of the DC supply, not on AC. In spite of we are using the AC in our house, but all the electric component is working on the base of the DC supply. So in each and every component, the converter is given to convert the AC signal into the DC signal. Why the DC signal is required? Because the AC signal is varies with time, while the DC voltage is constant with time. Constant with time. Okay. Now listen, what is the rectification? The process to convert or the converting AC signal, that means the AC current, AC voltage or the AC power into DC signal. This process is known as the rectification. This process is known as rectification. And what is the rectifier? The circuit or the device which converting this AC into the DC signal. That is known as the rectifier. Here we are going to discuss the use of the PN junction diode as a rectifier. Here the two types of the rectification take place. One is the half wave rectification. Second is the full wave rectification. Clear it? Okay. Now first the definition of the again rectification. The process of converting AC signal, that means the voltage, current and power into DC signal, is called the rectification. Again, the definition of the rectification, the process of converting AC signal, that means the voltage, current and power into DC signal, is known as the rectification. Now what is the rectifier? The circuit which performs this process, or the circuit or the device which converting the AC signal into the DC signal, is called rectifier. Is called rectifier. Now we are going to discuss about the half wave rectification. The circuit diagram of the half wave rectification is shown in the figure. Here the transformer is required. Here the pure AC signal or the main voltage is given to the primary coil of a transformer. Already we discussed about the construction and working of a transformer in chapter 7. Right? Here the AC signal is applied or connected with the primary coil of a transformer. So whatever the voltage we obtain across the secondary coil, this voltage are same. But here the phase difference is 180 degree. Therefore here negative is given, so here we obtain the positive half cycle. 180 degree out of phase. This signal is only for your understanding. Right? Okay. So the half-wave rectifier is made of a transformer, PN junction diode, and load resistance. To prepare the circuit of the half-wave rectification, transformer is required, PN junction diode, and load resistance is required. The primary coil of a transformer is connected to AC main voltage. There is the primary coil, there is the secondary coil. Primary coil is connected to a AC main voltage, and the secondary coil is connected in series with PN junction diode and load resistance. All are in series. Again, in half-wave rectification, the half-wave rectifier is made of a transformer, junction diode, and load resistance. Right? In next paragraph, the primary coil of a transformer is connected to the AC main voltage. AC main voltage. While the secondary coil is connected in series with PN junction diode and load resistance RL. The required AC voltage is obtained between the two ends, between the A and B ends of a secondary coil of a transformer. Required voltage is obtained between A and B end of a secondary of a transformer. Now, there is the supply voltage or the voltage across the secondary that is applied between the A and B. There is the time varying signal or the time varying voltage. There is the positive half cycle, there is the negative half cycle. During the first positive half cycle of the AC voltage, A is positive, B is negative. A is positive. Now keep in mind the definition of the forward bias of PN junction diode. When the P semiconductor is connected with, or the P end of a PN junction is connected with positive terminal of a battery, and N side of a PN junction is connected with negative terminal of a battery, so PN junction is in forward bias. Right? So here the P type of semiconductor, the P end of a semiconductor is connected with the A. Now A becomes the positive and B is negative. B is connected with N of a semiconductor. Therefore, PN junction diode is in forward bias. During the forward bias, the electric current flowing to the PN junction diode due to the majority charge carrier. Therefore, the current flows through the PN junction diode, low resistance, and VA. This direction the current is flowing. Thus, the current flowing through the low resistance R in the direction from X to Y. Understand this thing? Again, repeat it. During the first positive half cycle of AC voltage, A is positive, B is negative. Thus, the PN junction diode is in forward bias, and current flows through the low resistance RL in the direction from X to Y. Actually, the current is flowing in the path this direction. That is shown by the arrow key. Here, therefore, output voltage is obtained across the load resistance RL. According to the Ohm's law, V is equal to IR. Therefore, here I into load resistance RL. That is the output voltage. Is obtained across the load resistance R. Now, as the time changes, so here when the negative half cycle is applied between the A and B, during the second half cycle, A becomes the negative, B becomes the positive. Now, A becomes the negative, that means the P end of a semiconductor becomes negative, end of a semiconductor becomes the positive. Therefore, PN junction diode is in reverse bias. In reverse bias, the current is flowing due to the minority charge carrier. But this current is very small, is in order of microampere. Therefore, no current flowing through the PN junction diode in reverse bias mode. In reverse bias mode. Again, during the negative half cycle, A becomes negative, B becomes positive. So, PN junction diode is in reverse bias and no current will flow through the load resistance RL. No any current is flowing through the load resistance R. Clear it? Okay. Now, during the next cycle is positive again. That is the first positive, negative, again positive. Right? During the half cycle of incoming cycle, the current flow through the I because the next cycle is positive. Again A becomes positive, B becomes negative. PN junction diode is in forward bias, current flowing through the I. Next cycle is negative. Again A becomes negative, B becomes positive. PN junction diode comes into the reverse bias, no current flow. Therefore, during half cycle of incoming cycles, the current flow in RL in X to Y direction. The AC voltage to the end of R and waveform of input and output voltage are shown in figure B. So there is the input voltage or the waveform of input voltage. And there is the waveform of output voltage across the load resistance R. This type of the input receives the voltage in one direction only during the half cycle of each full cycle of AC signal. But no voltage is received during the second half cycle, hence it is known as the half wave rectifier. Clear this? Again, this type of the input receives the voltage in one direction only during the half cycle of each full cycle of AC signal. But no voltage is required for the AC during the second half cycle. Thus, it is known as the half wave rectifier. That is known as half wave rectifier. Very easy answer this question, and frequently either the half wave rectification or the full wave rectification 100% asked in board exam. Clear this? So half wave rectification and full wave rectification are most of the part is similar. Only the small change in the circuit and also the discussion. The answer of this question, first the definition of the rectification and rectifier, after that description of the circuit. Now, how the working? We have to describe the positive half cycle and negative half cycle. During the positive half cycle, PN junction diode is in forward bias, while during the negative half cycle, PN junction diode is in reverse bias. Right? Therefore, during the positive half cycle, only the current flows to the load resistance R. During the negative half cycle, no current flowing to the R. Thus, we obtain the output voltage across the R only during the positive half cycle of each full cycle of AC voltage. Therefore, that is known as the half wave rectification. Clear this? Again, first, what is the definition of the rectification? The process of converting the AC signal, that means the voltage, current and power, into DC signal is known as the rectification. Again, the process of converting AC signal, that means the voltage, current and power into DC signal is known as rectification. Now, the circuit or the device which perform or which converting the AC signal into the DC signal is known as the rectifier. Again, the circuit or the devices which convert the AC signal into the DC signal is known as the rectifier. Here we are going to discuss about the use of PN junction diode as a half-wave rectifier. As a half-wave rectifier. The circuit diagram is shown in the figure. That is the transformer. Transformer contains the two coils, primary and secondary. Primary coil is connected with the AC main voltage, while the secondary coil is connected inside with PN junction diode, load and load resistance RL. Now, the description of the circuit, the half-wave rectifier is made of a transformer, a junction diode and a load resistance RL. Right? Now the connection. The primary coil of a transformer is connected to the AC main voltage. Primary coil of a transformer is connected to the AC main voltage. And secondary coil is connected in series with junction diode and load resistance RL. The required AC voltage is obtained between A and B end of a secondary coil of a transformer. The required voltage is obtained between A and B end of a secondary coil of a transformer. During the first positive half cycle, A becomes positive, B becomes negative. So PN junction diode is in forward bias, and current flow through the load resistance RL in the direction X to Y. Again, during the first positive half cycle, A is positive with respect to B. That means the A is positive, B is negative. Thus, the PN junction diode is in forward bias, and current flows through the load resistance RL in the direction of X to Y. Okay. During the second half cycle, A is at negative potential, or A becomes the negative with respect to B. Therefore, the negative terminal is connected with P. Therefore, PN junction diode is in reverse bias. PN junction diode is in reverse bias. And no current flowing through the load resistance RL. No current flowing through the load resistance RL. Yeah, only we have to discuss the two cycles, positive and negative. During the positive half cycle, PN junction diode is in forward bias, current flowing through the load resistance RL. During the negative half cycle, PN junction diode is in reverse bias, no current flowing through the load resistance RL. Thus, during the half cycle of incoming cycle, the current flows in RL. Next, incoming. During the half cycle of incoming signal for the cycle, the current flowing, because the next incoming cycle is positive, again the PN junction diode becomes the forward bias and current is flowing to the RL. The AC voltage to the ends of RL and waveform of the input and output voltage are shown in the figure. Again, the AC voltage, input AC voltage and output voltage across the end of a load resistance with its waveform is shown in the figure. That means the figure B shows that input voltage, AC voltage and voltage across the load resistance are. Now, this type of the input receives the voltage in one direction only during the half cycle of each full cycle of AC voltage. Again, this type of the input receives the voltage in one direction only during the half cycle of each full cycle of AC. But no voltage is received during the other second half cycle. So it is known as the half-wave rectifier. That is known as half-wave rectifier. Okay, to obtain the output voltage across the load resistance during the both half cycle, here we only get the output voltage across the load resistance I during the positive half cycle. During the negative half cycle, no voltage is obtained. Suppose we want to obtain we want to get the output voltage across the both half cycle or during the both cycle, positive and negative. For that purpose, we have to connect the two diodes. So as a result, when the one diode is in forward bias, second must be in reverse. When the first diode is in reverse bias, second must be in forward bias. Thus, we obtain the output voltage across the load resistance RN during the both half cycle, and this process is known as the full wave rectification. We discuss next the full wave rectification.